So the point I'd like to, there's a couple of, in many ways, the key point to make out of this whole talk is not so much the results, but our method. And that is a bunch of people getting together of like-minded teachers, discussing what they're seeing, theorizing, speculating, if you like, about what their students can do. And then, and here's a crucial step, we then say, well, what sort of exam questions could we ask in order to prove or disprove our particular intuitions? And doing that, we had added, to Mike's stuff, we'd added a couple of levels in this sort of taxonomy of difficulty, if you like, all through a bunch of like-minded teachers getting together and talking and then running an experiment. And for that matter, following on from the question I just answered, doesn't have to be a bunch. You could have an idea of your own and run it with your own class and publish that as well. So that's really the big take-home message. But as I was saying earlier, the trouble with the by the end of the second pass through was, I better back up for that, we had established that connection quite firmly, I think, in the second time through. There was a relationship. People could trace, but they couldn't necessarily tell you what the code did. But it was speculative to say that there was a connection from that to being able to write. So that's what we started to worry about coming into our third iteration. And here we go. So in our third trip around, well, of course, the papers that we'd published in the first bracelet years, 2006, 2008, became the input, if you like, to our next trip around the cycle. Oops, something was about to appear, was it? Oh, yes, and of course, our output was the papers we published between 2008, 2009, 2010. Now, what was our method this time? Well, no big surprises. We effectively added to the existing experiment. Again, we gave students some tracing tasks to do, and while we're at it, that's comprehension level, Bloom. And we asked one or more explaining plain English tasks, and I've asserted that they were analysis level of Bloom. And all we did was add to that, well, if you want to see a connection between explaining and writing, well, add a writing problem. We asked the students to, solve one or more writing tasks, which is kind of at the application level. And by the way, if anybody's a little bit, I know I'm using the old words, analyze and apply would be, I think, what the revised taxonomy uses. Some of you might be a little bit worried that I'm essentially seeing if there's a relationship going up from analysis to application. Not really. As I said yesterday, the Bloom levels fall pairs, and Bloom was never too worried about which came first, application or analysis or synthesis and evaluation. Though their ordering was interchangeable as far as he was concerned. So there's no real dilemma in saying is there a relationship from analysis up to an application problem like that. Anyway, so we've got the three tasks. Give the students that. Now in a final exam, once again we're just using our final exam. And our prediction was that there would be some sort of relationship between tracing and explaining, the ability to do those skills and the ability to write. Now, I don't literally mean a plus sign like in addition. We're just saying tracing and explaining. Maybe an and sign would have been better there. Okay, so let's see what happened. Now, due credit, I have to give, being a researcher, I have to give due credit. The first paper, I was one of the several co-authors, but the first paper was first authored by Mike Lopez, who did the statistical analysis in 2008, but I'm not going to present you with that one because that one's harder to understand than another paper. So I'm going to go with the second paper. And that was a paper I did in conjunction with Anne Venables and Grace Tan. I didn't have time to write a slide for it, so that's why it says, it's instruction to me, tell the story about Anne and Grace. Effectively, Anne and Grace were two very dedicated teachers teaching at another Australian university, and they came to me and said, hey, I've seen the work you've been doing with the bracelet people on that sort of stuff. We'd like to do something like that too, if we could. And so we effectively did this experiment where we gave, in the final exam at Anne and Grace's institution, we gave the students three tasks. Anne and Grace, by the way, designed the three tasks, all the tasks in their own exam. They wrote their own exam, but we just chatted about, the design in general terms. And then we got the results. And that's, by the way, I'm just repeating what I said to the gentleman who talked earlier. How many data points did Anne and Grace have? So this is data from one institution. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28. There you go. So roughly 30. I might have miscounted.
Thank you, Prof.
Yeah. Now, so what did we do? It was very simple. It was just a linear regression. we said, what did the students score on tracing questions and what did they score on the explained questions? There were several tracing questions and at least 2 explained questions, but that's a detail that I don't think is important right now. Don't worry about these coefficients. They're just an artifact of the whole multiple regression process. Just think of it as score on tracing and score on explaining questions combined. And you can see it runs from up to, I guess because it says 30, the students could, no, I don't think so. I think these students were scoring the maximum possible mark. So 20 something on the tracing explaining questions. And on the left-hand axis, what we're plotting is the performance of the students on more than one writing task. I can't specifically remember how many there were or what they were. Okay, and then we just put a line through it, linear regression. We'll debate this now, I suppose, but some of you might think that's a bad fit to the data, that line, or some might think it's a good fit. Let's start with the raw statistical consideration. Firstly, it is a statistically significant at the 0.05 level result. That writing was predicted. I'll put predicted in inverted commas because strictly speaking, you could argue that writing was predicting this the other way around. It's a correlation, but I'll talk in terms of prediction if you don't mind. So it's statistically significant. Now, if you're not familiar with this in stats, R squared is a measure of how well your points fit the line. And an R squared value of 0.66, well, if you were doing a physics experiment, you know, from physics experiments at high school, I remember rolling ball bearings down an inclined plane and measuring something. I can't remember what that was, but whatever it was, you might expect a tighter fit to the line because physics is like that, or certainly Newtonian physics is like that. But people are messy. People are very, very messy. You never get, well, I can tell you that psychologists start getting excited when they do experiments with people if they get an R squared of 0.4. That they regard that as a great fit. So an R squared of 0.66 on this experiment using messy people is by statistical standards, by psychological standards, is a great fit. And if you still don't believe me, and that's fair enough, let me put it to you this way qualitatively. I've drawn a big circle there because what I'm trying to point out is that nobody who did poorly on the combined tracing explaining course, nobody who did poorly in that did well on writing, just nobody. And equally, nobody who did well on tracing and explaining here did poorly on writing. And we can debate whether this is a good result or not. I have been claiming it is for some years, so I think I'll leave it at that for the moment, unless some people want to later debate it with me. It's a great result. As far as I was concerned, we demonstrated the relationship to writing. And remember, before I get to anything else, these are just questions in an end of semester exam. You can do something like this yourself. All we're trying to do is move our understanding of our students along by using our exam, not just as a way of assigning a grade to a student, a point score to a student. We're also using it as a diagnostic tool to try and figure out what's going on with our students and why they're having problems learning. And all we're doing is putting questions in an exam that we have to write anyway. I just want to repeat my slogan from earlier. A good exam should teach you something new about your students. It's not just a way of assigning a point score to students. It should teach you something about how your students are learning. And usually, to back up just for a second, most of our analysis boils down to giving different types of tasks to students and then analyzing, well, they can do well on this, but they can't do well on that. It's comparing their performance on one task with another. Okay, so by this stage, by our third trip through the cycle, we felt that we'd established this, that there was at the bottom there were students, well, not necessarily at the bottom, but low on the taxonomy, students aren't able to trace code. Then further up, we think that although some students can show they understand what the blinds of a piece of code do, they can't see what the overall algorithm is that emerges from that code. And we think that's a prerequisite. Well, we think that graph that I just showed you, that one there, was a pretty solid indication that you need these sort of skills, both of these skills, to be able to write code. Oh, okay. Actually, it's not a linear hierarchy like I've drawn there. That was a little bit of surprise. That was what we hypothesized. It would be a linear hierarchy. Like, turned out it was actually a little bit more complicated than that, and it won't take long to explain that. If you look at a student's score on tracing questions and look at their score on writing, so tracing and writing, there's actually quite a weak correlation. And equally, if you look at just the score on explaining questions and writing questions, it's a weak correlation. It's the combination of the two that turned out to be the really strong indication of performance in writing. You need both skills. You need tracing and explaining to do the writing. Oh, and furthermore, I think that arrow is supposed to grow by itself. Let me see if I got my, there we go. Yes, look at that. Or look upon my PowerPoint and despair. What we found was that, initially students, students reach a point where they can trace, or I guess I'm asserting this more than saying what we found. Students, and then on the basis of tracing, they slowly develop the skill of reading code, sometimes often by tracing lots of code. They slowly begin to understand, code in a more abstract way by being able to explain what it does. And then finally, after they got pretty good at both of those skills, then the code writing skill begins to emerge. Well, because Microsoft Teams, I don't expect to. The first take-home message many slides ago was explicitly teach and test tracing. It's a foundation skill. But make it fun. Try to make it fun. The second take-home message. Well, yes, tracing skill alone is not enough for code writing skill. Tracing skills helps develop explaining skill and understanding of code. And I'll assert that last point here, not quickly, be patient. I think we overestimate at tracing and a lot of practice then at explaining before they develop quite a good skill. And only after, and that's really what I'll talk about a bit about tomorrow. And then only after they've got both skills do you start to see a ability to write code. Now, look, if enough monkeys type long enough, eventually they'll type Hamlet, right? Is the old expression. If you sit a student down in front of a computer and tell them that their exam, their passing, failing will depend upon them writing a piece of code, of course they'll try to write a piece of code. But what will they do if they can't trace and or explain? They'll try their hardest as best they can, and they'll probably hand in a pretty incoherent program after a very incoherent approach to writing. What we're really saying here is that only a coherent, methodical approach to writing, that will only appear after students have got these two skills. All those students that you've seen hammering away and randomly changing their code, and you exhort them to be more methodical. Well, you've got to do, I think, more than exhort them to be more methodical. You've got to teach them the underlying skills that will make them more methodical. If you can't trace, if you can't trace, let's forget to explain it. If you can't trace, how can you debug your own code? I think that's an obvious question, and it's worth repeating. If a student can't even trace their own code, how are they ever going to debug it, other than by random permutation? Okay, so tomorrow we'll take the fourth trip. Do I have a little preview? Oh, no, I'm just going straight to my conclusions. A good exam should teach you something new about your students. If you've forgotten everything else about this talk tonight, I think that's the lesson you should learn. Look to your exam to teach you something. Design your exam, write questions so that next semester you'll know a little bit more about how your students are thinking. And that's the end.
Thank you very much. That sounds very, very, very good. Bertie, I think you can start with some of your questions that you got.
All right, thanks. Some of them I think I've actually received 3 questions where documents was attached, so I tried to anonymize it to the best of my ability. But while we are here, while I'm just getting it ready, one was sent in for Prof, and Prof listed the question read as follows. While I get myself up. Oh my goodness, now I've lost it. Just 1 second. 1 second. Oh, the question read as follows. Considering that in the first semester at university often covers a lot of the work that we do in our 3 years at school, programming, grade 10 to 12, can we or could we consider our learners as that is in school and regard them as novices? Professor, what's your take on that? True or false was the question.
Good question. Could we regard them as novices? I mean, I did show a slide quickly yesterday, and let me see. If I can share, Bertie, I think I'll share again. I think that's the right. Are you seeing a picture of a rocket right now? Are you?
Yes,
Yes, you are. Good. Now let me see. This will be quick, I promise. I don't want to take two. This is talk 2. Tomorrow's talk 3. 26th. That's the one, is it? Yeah, this looks like it. View slide sorter. Now, this is a question that I was involved in writing this exam for our high school students in 2013. So this is their end of high school. They've done 2 years of software design and development, a subject called software design and development, when they sit this exam paper. And this is a multiple choice question that we gave them in the exam. Length is set to 0, breadth is set to 0, area is length times breadth, and then we initialize length and breadth to something non-zero. And the correct answer then is, well, when this code is, what the values of length, breadth, and area after this code is finished, well, length and breadth will have 5 and 4, but area will be set to 0 because we did the calculation, didn't we, before we did that initialization to 5 and 4. But in fact, 30%, almost a third of the students who'd studied this high school subject for 2 years chose option D. So my first point is, rather than accepting that students coming into the university are not novices, I would test them. I would give your incoming students a test. And so rather than whether they've done the, obviously it'd be voluntary because the people who haven't done any programming at all, there's no point in them doing the test, but the rest should do this test. And then you should make a decision on the basis of a test, whether they are novices or not. As a policy decision at UTS, we largely threw into the one classroom students who had done high school programming and students who had not. And I used to begin, part of my first lecture was to simply apologize to the students who had done some programming that they were going to be rather bored for the first few weeks while I covered what they already knew, but there wasn't anything else I could do. At the policy level, the university decided to run one course. And I was not going to leave behind in lecture 1 all the people who, we advertised the subject as an introduction to programming with no prior experience in programming, and therefore that's how I taught it. Unsatisfactory arrangement. I guess you've got to look at the paperwork. If your subject at your university is listed as being an introduction to programming with no prior experience required, then that's what you should teach, in my view, because the people are buying your course on the basis of the promotional material. Is that ideal? Probably not. So then talk to your management about having more than one class. I'll tell you one thing, what we did do was that we were able to establish, or a colleague of mine was able to establish, who in my class were not just students who'd done some programming, but who actually were quite good at it. And she used to run a project off to the side where these students worked on actually they worked with industry clients, those students. So we moved them off into a side project and gave them a productive learning experience that way. That's a bit extreme. You may not want to do that sort of thing. It might be too hard for your institution, but you could always move those people over into some sort of a side project and try to keep them entertained that way. Does that answer the question?
Yes, I think you've answered quite a lot of it. I think the question was a lot around the emphasis that maybe we tend to expect too much of high school learners and maybe have concepts in a high school setting that is maybe, too advanced or something like that to like you stated, many of them will then find the first semester not such as a challenge, but we need to consider everybody that comes in to do a course. And at our university, that's a typical reality where we even have some foundational bridging courses to assist the students even more. There was another question, Prof. Raymond, based on your university, could you just give us a two-sentence overview in the department that you was, up until which level did the students go with programming? Yesterday you showed us some examples of apps that students develop, but can you just give us a 2-minute background or a minute background in a few sentences about what did you do in your university? Because some of the colleagues, and it was a question from one of my colleagues, asked, where did you go up to? Because I think in their mind they want to do a relate your university to what we're doing and just seeing how it compares.
Okay, so do you mean the whole of degree? How do they progress?
Yeah, just a snapshot overview of the type of programming, that they only have one subject programming, or that there are 2 or 3 different, that type of.
Okay, so the students do a degree in information technology, which can split, they do effectively a common first year, and in that first year there will be 2 programming subjects, one in first semester, and most of my experience was in that first semester, and then there's one in the second semester. At the end of that first year, students start to decide what major they will do as part of their degree, and effectively that boils down to, well, 3, I think, which is software engineering, on actually 4 these days: software engineering, systems programming, if you like, and as a second one. Third one is kind of information systems, and then the 4th, which is relatively new, is data science. I can't say much about the data science one because that was quite new, and I didn't have much connection with what programming they did in that. Information systems people tended to not do any more programming after the first year. The computer systems people and the software engineering people went on to do quite a lot more programming. The very first thing they do in the 3rd semester would be a fairly orthodox data structures course. And like many data structures course, they also introduced the second language to the students. So they did Java, and when I was teaching, they did Java in second semester. Then when they did data structures, I think they did it in C++. Then after those, that was like the first 3 subjects that introduced them in a very rigorous way to programming. There are a plethora of other subjects that teach them things like, how to write programs that will run across the internet and so on. And I couldn't enumerate all the sort of subjects that do that sort of thing. All I can say that by the time they reach their 3rd year, we have what we call the Capstone Project. You may have it too, because it's quite a common thing to do in lots of countries. And so they would be given a large project to do over the course of at least 1 semester. I think it was only 1 semester by the time I finished. Sometimes it ran for 2 semesters, the entire 3rd year. They would work in a team. In some cases, they might have a real industry client. In other cases, they were given a pretend client, if you like, which may have been me or another academic. And they effectively simulated a whole software development process of listening to the client, defining the requirements, then building the software and so on. Does that answer the question?
Yes, Prof. And I think a lot of my colleagues and from the other people here from other universities and universities of technology will completely relate to what you've stated, and it's mostly the same in many of our universities as well. So thank you. It was just one of my colleagues that asked that, and I think you've answered it quite nicely. It's a bit out of the scope of the talks, but I mean, it gives us some time to relate and some time to get into some discussions. I would like to share my screen because for the other questions that I have, people have sent me in documents, so I try to anonymize it to the best of my ability because I don't want to put names, and it's just for the sake of the question. So I'm going to share my screen and have it open, and then we can discuss it through. I really double checked and triple checked to see that it's really anonymous. So I'm going to do that. Let me just see which one we can take. So here we are. That's it. Can everybody see my screen? Prof, can you see?
Anonymous question. Yep.
There we go. There we go. So the one that was at our university, we have an ordering type question in our learning management system. As seen in the example below, pieces of code segments are given to the students, and it's expected of them to arrange it in the correct order to solve the problem. What levels of blooms would Prof say this question will be associated with? Most students struggle to answer these types of questions correctly, even though all the code is given to them. Is this on a higher level of blooms? I enjoy these types of questions for online assessments, since students are not able to access the computer to write and submit code. So this is just a typical, the user must enter something, and then it's a Java program import, and then they must say, if you want to write a program like that, they will have some paper to conform it. And obviously that will need to be your first statement. Then they need to select, for example, where's 2 now? This is the next statement, and they need to order it in the correct way. So you give them fragments of code and they must order it. So how would you see, and how would you potentially classify a type of question like this, where all the code is given and it's basically scrambled, and the student needs to descramble it?
Okay, but by the way, in the case, at least in Australia and New Zealand, and I think these days in America, these types of questions are known as Parsons problems, because the first time we saw them in Australia and New Zealand, and probably America, they were being promoted by somebody called Dale Parsons from a polytechnic in New Zealand. So, by the way, if the person's asking if you want to know more about what people have found using that sort of a question, you might Google Parsons problems and see what comes up. Now, what category are we going to put it in? Well, I shall make an assumption, which is that the assertion was made that all the necessary information is provided. So on one hand, that would argue for comprehension. On the other hand, it does look quite difficult, doesn't it? Now, difficulty doesn't necessarily relate to bloom levels. You can have an easy or difficult application question. You have an easy, difficult analysis question, an easy, difficult comprehension question. So I would say this is at least a difficult comprehension question. I'm tempted to say it fits into the application. I suppose, well, there you go. See, I mean, you might argue in a way that it's analysis, isn't it? Not that I care too much about whether it's application analysis. The choice between those two categories, because the bloom levels come in pairs, I'm never too stressed about whether somebody says, well, this is really an application, it's not analysis, because it just doesn't matter that much. So the real thing comes down to, is this comprehension or is this application/analysis?
Thanks.
I think I'll stay with, it's a really difficult comprehension question. I'll stay with that. But if somebody disagrees with me, I probably won't challenge them.
What I would like to just point out, and this you've pointed out very wonderfully, Professor, because in the domain that I'm working with, there's often a misconception regarding the difficulty level of a question and the cognitive level of a question. So while we are on that point, can you maybe, I know it's on the spot, but can you maybe give us a little bit more of your thoughts on that, if possible?
Yeah, I think that's going to be an easy question to answer, Bertie, because I'm not sure I have many thoughts. I suppose one place that you might go to think about it, so I'll is perhaps this is where the the revised taxonomy may have an advantage. Now, as you've gathered, I am partly an old-fashioned stick in the mud who learnt the original taxonomy and never felt a great need to modernize himself by having a look at the revised one. The revised one, I regard the revisions to the level naming and the reversal of synthesis and evaluation and it's relatively trivial changes, but the really substantial change that came with the revised taxonomy was a whole second dimension, and I can't, beyond my awareness that there's that second dimension, I can't say much about the revised taxonomy, but that might be a good place to go and think about. It might offer some insight into what's the difference between a difficult and an easy comprehension question, or what's the difference between a difficult comprehension and an easy application question. That's the best I can do.
No, but that's already food for thought. And thanks, Bob. Let's move down to the other one, anonymous concept. This one we did do, the true or false one. If Prof has background on SQL, how would one classify different SQL statements? A join, in my opinion, is of a high cognitive demand or higher cognitive demand than a select, for example, with an aggregate function. Any thoughts on this? I add some questions a part of a larger exam that our grade 12 learners write. So this people added a question like here, and then they get, for instance, different types of SQL questions. Now, this is typically from our high school exams, and they just ask that if you, for example, looking at SQL, would Prof think that questions relating to containing joins in tables are of a higher order or of a lower order when you just do a typical select, for example?
Yeah. Firstly, do I know anything about SQL? I know a little bit because I had to teach introductory database for a number of years, about 10 years really. And but I also, I'll say this caveat. I mean, I know nothing more about databases than what I taught in my introductory course. So yeah, I do know some simple SQL queries. Now, it depends, I think, on how you phrase the question. When I used to have tests where the students had to write SQL queries, and usually in those I would nominate that by some method what type of query the students had to write. For example, was it a join, or did it involve a group by, or something like that? So in that sense, I was, if you nominate what's required, what sort of a operation, what type of query, then I think you're heading towards comprehension, assuming that in nominating the type of query, you've provided all the necessary information. I used to provide students with an ERD, and I think if it was a join, I would probably nominate all the tables that were required. I think I did, I'm not sure. So you're heading then towards comprehension. If, on the other hand, you don't nominate what's required, if you just phrase it as a, give me a list of all the different products that we make and tell me how many we've sold of each one, starting to sound like a group buy to me. If you don't mention group buy, if that's what you give them, I think you're heading into application, because now they have to realize that a group buy is required.
Yes.
Does that answer the question?
Yeah, fantastically, Prof. Fantastically. So even then, looking at the group by and looking at, for example, a join, it depends on how the question is phrased. If two tables must be joined with a primary key and foreign key, and it is explicitly stated in the question that type of information is given, then it lowers the level, as if when the student needs to figure it out, for example, on his or herself by inspecting the relational diagram that's given. Because typically, for school kids, the relational diagram will be given. Then we've got another final one. I think this is all right. Dear Prof, what are your thoughts on a question paper that assesses the concept of OOP, but the progression from one question to another are dependent on the success of the learner of the first question? I think this question forms part of a accounts a practical exam that counts 120 in total, of which the OOP question count 80 marks. So I had a quick scan when I get it. So what they have is a bigger object-oriented programming scenario. Then it seems they give the scenario with a UML diagram. Then there's a question 2 where they design a new class there. It looks like student with some methods over there and a toString method and so forth with accessors and mutators. But then the question gradually builds on. Question 3, then create a new class called grade, and it then builds up. It seems that you are going to require the answer of the previous question to kind of be successful and to implement. Yeah, here they talk about create an array to store up to 50 student objects, and then another array to store up to 5 grade objects. So it's kind of, it seems like aggregation and so forth. I didn't look at the question in detail. I was just too scared. I was just anonymizing everything. But what is your take on that?
First, I got a question. Is this a paper-based exam or is this something they're doing online?
No, this is practical. This is a practical exam.
So it is an online exam.
Yeah.
Okay.
They sit in front of a computer, and I know it's part of a 3-hour exam where this OOP question counts about 80 marks, and there's 40 marks of SQL statements that's in the beginning. So this is a practical, what they call a practical exam, and it's a high school, and I can tell you now it's from our schooling system.
Now, yeah, I think I'll avoid saying whether it's good or bad. I'll talk about strengths and weaknesses instead. The strength, I think, is that you really are, in principle at least, in theory, separating the students out into those who can do some of the basics but can't do the more complicated things. And that's good. The weakness, I think, is if you've got a student who basically can do some of the harder things, the higher level things, but for some reason they've just made a dumb mistake in an earlier one, and they can't seem to be able to fix it. And you know, we've all had programming experiences where we've made a mistake, and for some reason, you know, we chastise ourselves later when we eventually find it, or somebody finds it for us because it was a dumb mistake. So I'm a little bit worried about students who are actually capable of doing some of the higher levels, but they are prevented from doing so because of some dumb mistake under exam conditions. So I'm having a bet both ways. In principle, probably my argument would be this may be impractical because it involves so much reading, you know, but you know, I would prefer to ask here's another one. How about this? If the online system was smart enough that the student could attempt something, one of the earlier stuffs, and then they can't do it, and eventually they just say, I can't do it, give me a solution, and you give them that, and then they can go on to demonstrate the high levels. That would be quite reasonable, I think. The hard thing there is that most students are gamblers by mentality, and they will back themselves to find this bug at some point rather than just to concede and give up in order to get a higher level. I think the type of question I'd like is one where you actually, in one question, you get them to do something at a low level, and then in the next question, which is a different scenario to the first question, you provide them with, you then ask them a higher level question from that something that's higher level than what you asked them in the first one. The problem with that sort of style, of course, is that it just leads to a lot of reading, and you know, they have to assimilate a lot of material in order to answer the questions. And you know, I don't know how long you said the practical was, but you know, that could be difficult. They may not have enough time to do all that reading. So is that an answer, or should I can I elaborate on that in some way?
Sorry, Prof. Lister.
Yep.
If I could just interrupt and give a bit more context.
Yes, please. Hello? Go ahead. Yep. Go ahead.
Yeah, it's a 3-hour exam, but it's not marked as doesn't compile. You don't get any marks, or doesn't run. The code is actually marked piecemeal, so individual methods and things like that. So the ability to score marks throughout is there if they just keep coding and write some code.
Oh, okay. So just let me clarify. When you say it's marked, it's like a manual inspection. You actually look at the code.
Yeah.
Yep. In that case, I think that's a good way of testing. Yeah.
Yeah, it seems to work well, and yeah, I think if you look at some of the graphs of our distribution, that's why I think we're getting a lot more in the middle.
Yeah.
Yeah, because we do give them part marks. Even for an SQL query that's a complete join, like even if you just select the right fields, you'll get 1 out of the 6 marks or whatever. So it's all manually inspected by markers.
Yeah. Oh, good. Okay. So I guess, yeah. So just for the benefit of other people, if you had an automatic system which wouldn't allow the student to move on to the next part of the question until they actually got the first part right, I'd worry then about those students in that automatic approach. But given that you're marking manually and exercising some judgment, I think that sounds like a really good way to test students.
Yeah, and as for the reading, I know they do get 10 minutes reading time prior to the exam, so they can read before they start. But your reading length is always a problem. I think, yeah, there's some of our exams which span kind of 15, 20 pages. But the language is checked quite carefully there as well for readability and things like that on a national level. So, yeah.
I have been known to sit in meetings, and because you said this practical is 3 hours long, is that right?
Yeah, 3 hours long.
Yeah, okay. I sometimes query whether what we're really testing is the bladder capacity of our students in a 3-hour exam, but
I think a lot of our school leaving exams are 3 hours.
Okay. Well, as long as that's the environment they're accustomed to, that's fine.
Yeah,
I'm sorry.
They are accustomed to it.
By the way, in Finland, they sometimes have exams that run practically the whole day. They even bring food into the exam room. Yeah, they bring food into the exam room in Sweden. They cater their exams.
Prof, I guess there was another question here in the chat room. And do you track the performance of your students at the end of their qualification? For example, if you look at the finger painters, how did they perform towards the end of the qualification?
Okay, I can't. No, as far the furthest I went was the third subject. I had a slide yesterday, I think, where we showed that some of the students, the finger painters, so they got the lowest passing grade in my subject, but they did quite well in the third semester. I could find that slide and show it again, but I think I'll just leave it since it's in the first talk. I'll just say qualitatively, a lot of them, of course, got another bare pass, but you'd expect that, irrespective of how you teach your students and how you assess them. The students who get a bare pass in the first subject, if they pass in later subjects, you'd expect a lot of them will get another bare pass again. But some of them did better than that, and some of them, in fact, went on to get the highest grade. And we have 4 passing grades, so some students with a bare pass in the first semester went on to get the highest grade in the third semester. So they're not streamed, if that's kind of what the question's getting at. I can't go beyond the third semester. I have no data about how they go from then. The only thing I can relate is one interesting anecdote. We had a student who volunteered for, I'll talk a little bit about Donald tomorrow. He volunteered for a study that we did where we focused very much on individual students. And Donald was a fantastic student to study because when he came to us, he was terrible. His programming skill was just almost non-existent. But Donald had this wonderful attitude about learning. He was very dogged and determined. And he went on to do quite well in programming in his degree, and in fact, then went on to work as a programmer. So I will maintain that anecdotal story is an indication that if you're patient and teach the basics well, students will teach a lot of the rest of the stuff to themselves. I think where we fail a lot of the time is we rush to get them to writing large quantities of code, and they don't have the basic skills. I'll go back to what I repeated earlier, which was asked earlier, which is if a student can't trace their own code, how are they going to debug it in the early years? So I think we've got to make sure the foundational skills are in place, and then they'll teach themselves a lot of the rest.
Thanks, Professor.
Does that an answer to the question?
We've got another question. Yes, it does for sure. What is the lady posted? any thoughts on the length of reading a question? What is your opinion, or do you have any ideas on best practices with that regard? So how long, the length of the reading? You did allude to that, but any ideas or any further thoughts?
Sadly, this is probably could be the same in South Africa, but sadly in Australia, IT degrees, a lot of high school teachers who advise students, and a lot of parents who have kids who are fairly technically strong but weak in areas like English and so on, advise them to go into IT because, well, there won't be much reading in IT. And in fact, we know there's a lot of reading in IT. It's poor advice, but that means we do get a lot of students whose reading skills are weak. And I don't think I've ever sat down and done a quantitative study of this and written it up. I'm sure I haven't written it up, but certainly we've noticed, and this is across institutions, so we did this as part of Bracelet, we noticed that the more reading we had in a question, the less likely students were to get it right. And and it would seem a lot of students would give up at the reading stage if it seemed too difficult to read. So the less reading, the better. My approach to reducing the amount of reading is as follows. I mean, if I need a scenario in an exam, I give the scenario to the students before the exam. So I try to give the students as much information as I possibly can that's background to any of the questions without giving them the actual question itself. And that's proven to be pretty useful. That's worked pretty well. So the less, I don't know about how long the reading should be, but the less reading, the better. And the way that I have routinely reduced the amount of reading a student does while in the exam is to give them as much of the stimulus material as I can before the exam.
Thanks, Professor. That is a good answer. And I just in relation, when you talked about the Finnish system where they get the whole day, I know Prof. Van Vieren is still here, and some of my colleagues at our university many moons ago, we used to have a 6-hour practical exam, and the students could bring in anything. They could bring in their snacks, their tea, their whatever. And some of them really made a party of it, and that was always something quite fun and informative, and just to see them completing it. Because for me, it wasn't about the time. I always had the idea in my mind to say that students must be given time without working in a very big, stressful environment to solve some problems. Because when they go out one day, and we being University of Technology, with a little bit more focus on the vocational side, they won't be in a 3-hour situation where they will necessarily need to be or do such a big piece of code. So we normally used to have a 100-mark exam with not so many types of coding or coding required, and have them do it over 6 hours in their own time. And the good ones normally completed it in less than 2 hours, but the other ones had some time to complete it. There's another question on our chat group which asks, dear Prof, what is your take on teaching block-based languages at school level for teaching the basic programming concepts and principles rather than just focusing on industry-type programming languages? That was the one question. There is another question that's a follow-up on this, but let me just put this one as first.
Okay, the younger the student, the greater the more emphatically I agree that they should be using a block-based language. The way it currently works in Australia is that at the primary school level, the national syllabus, this is a bit complicated. Australia has a national syllabus, but then it's often honoured more in the breach than being faithfully implemented by the various states. But let's just stick with the national curriculum. National curriculum says that at the primary school level, the students will use a block-based language. And then in junior high school, they will, in their first years at high school, they will transition to a text-based language like Python or whatever. I'm not going to buy into exactly what age is best. I mean, I think there could be a high school teacher listening right now who, on the basis of their own direct experience with students, would tell me that students should continue using block-based in early high school. I don't know. I won't buy into that, but I will buy into that the earlier the younger the student, the better. they use a block-based. But I will say this, block-based are not a panacea. Students can get themselves into as much trouble with the block-based language as they can with text ones. They can. So it's not a panacea. But at least they're not trying to figure out where the semicolon needs to go.
Yes, thanks, Prof. All right, then follow up to that is another type of question. In really considering the concept of object-oriented programming, what role does the bigger picture, that means, and then they wrote in brackets, understanding the relationships, part of the whole, the flow, and the integration play in the cognitive demand of the question? Does that raise the cognitive demand? So in understanding OOP in itself, by knowing concepts like instantiation and so forth, does it raise the cognitive demand? Because you need to implement it as part of a bigger picture.
I think the short answer would be yes. But let me then walk slowly backwards from that, mostly through ignorance. As you might have inferred from my PowerPoint slides, my teaching still tends to be, although we did it in Java, we still emphasized procedural type concepts a lot. So I don't, and I have never taught a user interface library like Swing, whatever. So I'm relatively ignorant about this. It seems plausible to me that what you're saying is true, that if they need to understand how the things relate and so on, it's going to move up higher in the taxonomy, but I don't feel qualified to really be more specific than that.
Thanks, Prof. That is a very good answer. And in my own personal capacity, I agree to say that I think students, depending on their age, a third year or second year student that has had some exposure will think about it differently than, for example, a 17-year-old that is exposed to it for the first time, that is still in high school. That was all the anonymous questions that was sent to me. I do not know if there's anybody that still has another question maybe to ask or some comment that they would like to make. Anybody? Yes, I see Mr. Greuters has his hand up.
Sorry, Prof. Perhaps a bit of a controversial question. You're welcome to not answer it. You started off yesterday speaking about, obviously, the explanation being, well, Prof. List is a terrible teacher. Do you have any advice for, I mean, it's wonderful to say kind of that we want to look at students and user assessments and everything. Is there any way to diagnose like poor teaching and then to kind of rectify that? I think some of us are kind of in charge of other teachers or train other teachers or whatever the case may be. But yeah, I don't know if you have any experience or just an opinion on that.
Okay, there are certainly no shortage of poor teachers. See, I've worked in all my entire career was in universities that aspired to be greater heights in research, and so the management was always harassing people to do more research and to not spend so much time on teaching. I was a pretty awkward customer in some ways for the university because they couldn't quite categorize me since I kept maintaining that I did research. I'm researching education, and I saw a lot of people who were at least poor teachers because they were preoccupied with their research and they shortchanged their teaching. I certainly saw quite a few people who, shall we say, had a talent for teaching poorly. They just were not very good at it. How to solve the problem? Hard. I didn't like, I objected to, I didn't like the way that UTS went about it. UTS effectively tried to improve the standard of teaching and would have rules about what constituted good teaching, and then would coach people on what those rules were and insist that they do them that way. And I guess I was cursed in a way because I was a I was doing research in education. So I said, well, look, I understand where you get coming from with these rules, but they don't apply in certain situations because of. And then you're in a very awkward situation of you seem to be disobeying the management when you're not disobeying them. You're saying, as a researcher, I have a problem. Can we discuss it? I don't know how to solve the problem. There's a lot to be said for trying to force people to teach better, but it doesn't seem to work well. A lot of people who don't want to teach well end up then playing the game of going through the motions of making their teaching look like it's good. And yet, if you're intimately involved with them or their students, they're not teaching well. So I guess I don't know. I wish I did, but I don't.